Alright, so since that last video, Factor 55 contacted me and asked me if I had an extension rope, and I said I do not have one. So I asked them, why do I need an extension rope, and why are they asking me for this? And basically they want me to run an extension rope so I can measure both sides of the load for this retention pulley here. So I told them I don't have a synthetic rope that I could splice to do this, so they ended up sending me some free stuff. They sent me 100 foot of 3/8 synthetic rope that I could use to splice to make extensions for this test. I got 2 identical cylinders from a buddy, so that way we can have a cylinder on each side to do the load testing. I got 2 meters from work, so I got one to do voltage and one to do amperage simultaneously. And also I got their soft shackle that they sent me, which is really nice, by the way. Really feels really good with their data sheet, comparing my homemade soft shackle out of 7/16 Dyneema rope. But they also sent me a Haas and their rope guard for my Pro Link, so something to try out. So definitely thankful for that. We're going to do some testing later on, and we'll see exactly how much force there is on each side of that line in pounds. That way we know the total load, and we know the voltage and amperage to see if there is an inefficiency. How much is that going to cost you as far as duty cycle and winch time? So now we're about to go compare these 2 cylinders, make sure these 2 gauges read really close to each other, or else all of this is basically a big waste of time. So I'm going to get my cherry picker, go to the truck. I'm going to lift the front of the truck up off the ground, and we're going to compare the pressures to each cylinder and see where they're at to make sure these gauges are at least within 20 pounds or less of each other. All right, here's a gauge comparison test. Since I'm going to use 2 cylinders, I'm going to compare the pressures of the gauges to make sure they're accurate. 2 cylinders of the same brand. The truck is off the ground. So you can hear, let's see what pressure is. So it looks like 1275. And let's just say 1275 for that. So let's hook up the other cylinder. There's the first test there. There's the second one. Tires are off the ground, and the pressure is 1275. That's about 1275. So when we do our testing tomorrow, we can compare, and we know these gauges are within at least 20 pounds or less to give us an accurate representation of what's going to go on. The truck's in double low in 10-to-1 ratio, and it's pulling equally on both sides of the lines going through the snatch block. So the gauge side on the winch showing there about 575, and the gauge line on the side going back to the truck after snatch block about the same, 575. So it's an equal comparison, equal load on both lines to make sure that both cylinders and the gauges are reading correct. So now we're going to go ahead and load the winch up and pull on it and see what the pressure difference is between the 2 cylinders. All right, here's our test, a single line pull. This is going to a hydraulic cylinder for our reading, our load reading, and turn the winch controller on. And here we go. I'll wait for it to settle out. It's settled out. Right, so we got 2 meters, 40 voltage and amperage. We got it right now. We'll start recording. So now we're starting to record. All right, 2 guys helping out, holding the lines steady, and here we're gonna go pull. We'll let it settle out. parking brake settle out. All right, settled out. Meters get these too close. All right. All right, now we're gonna reset and we'll test. We tested the traditional snatch block, so we're gonna reset and test out this retention pulley. Two-cylinder snatch block configuration through the pulley. And let's put a load on it and get everything tight. All right, what? Be closer.
Careful.
Yeah. Put your hand, Richard. Yeah. Slipping a little bit. I think we maxed out, you think?
I mean, that pressure was not climbing anymore.
Yeah, we're at the end of our ordeal, but we'll put them together again. I'll go a little bit more. Let's see.
That's first.
Yeah, it's past our other testing, so we'll reset and compare our numbers. We just roughed up the rope. We noticed it's slipping. We weren't sure if it was from the fact that it was new, but we'll give it a shot, see what it does. Now I had to put the winch back in gear, but yeah, it's slipping with it's still slipping. Go closer. All right. Yeah, the rope was slipping a little bit, but then it stopped and then started pulling again. So I don't know if it's that waxy coating on that black rope or what. But the good news is we got voltage and amperage before and after,
Right.
with the slipping and not slipping.
It's higher than mine, so you're decent amount.
Yeah.
I'm almost.
No, you're at 1,000, and he's over.
Yeah, but earlier it was about 15.
Oh yeah.
It fluctuated a little bit.
Yeah, with it settling. All right, well, let's crunch some numbers, I guess. Done, but we'll do an extended pull and see what our actual temperature is. And it's showing 75.7. Yeah, 75 degrees. Let's do an extended run. We're at 80 degrees now. Pulling 5,000 pounds.
Ready?
Yeah, go ahead. I'm just going to get on this side of the sun. Let's see if I can see this a little better. So really no heat buildup at all. I mean, went up 10 degrees, pulling 5,000 pounds. That's probably good, Richard. All right. So it really didn't warm up hardly at all. I mean, same test, but this time it's with the Factor 55's extreme duty shackle in place. And also we're gonna put some more water on it halfway through the test to see if that does anything to the results. So let's go ahead and put some tension on it. A little bit of slipping on that. Yeah, it's not slipping at all with this one. Yeah, it's stalled out. It's not slipping at all. So what's our deal? Gauges together. About the bubble. Put your gate closer. Yep. All right. .82. That's not slipping at all.
I think it's 'cause this rope is slicker than the shackle.
It might be. It's got that waxy coating on there. I'm gonna let that off so I can get a measurement. It's 80. I mean, no temperature difference, even though it's dragging across the inside.
Check the inside?
Yeah,
What the
it's the same.
inside temp is?
I'll check the outside on there, on the inside of that deal, but yeah, it's no difference on that, on temperature, for that low pull. So I guess that's worst case scenario for drag, because I mean, you got the pulley not even turning at all. And if anything, we should definitely see compare that to the other video.
Like it's a super, is this their rope?
Huh?
Is this their rope?
Yes, that's the rope they just provided me an extension rope, and this is it's a black coated rope. It's pretty waxy feeling in comparison to my my silver rope, so I don't know if that's the case, if that's causing any slippage on that. Spinning on the other one just fine, but this one here is starting to slip on that one. So, but this still, compared to our other tests, this will show the pressure differences between the two cylinders, and this is like worst case scenario for drag, to see how much we're actually going to lose. Because
Did you already put water on it?
no, I didn't, because there's no point. It's slip on the inside.
Yeah.
So I mean, given where it's slipping, that's worst case scenario on drag. And I guess we'll just test to see how slippery that type 3 anodizing is with that Teflon that's coated. So even if it does lock up, to see what your efficiency is, I guess depends on the brand of rope you use, right? I mean,
I was gonna say that, like, if you use a cheaper knockoff one that might be too slick, causing an issue. But
yeah, with the wax coating, yeah. Well, this is not. I don't know if this is. They don't have a brand of rope.
Oh, okay, the one.
Yeah, this is, who knows what brand rope this is.
Yeah,
I mean,
because
it could be,
just doing promotion, if they could have just sent you another one from Amazon.
yeah. But with my used Smitty built rope, I never had the issue on my test of it just rotating like that. It always rotated. So I guess we can pull the truck up closer with their shackle, and with the same amount. Yeah, the amperage will be a little different because my concrete's been buffed one way and another way, east to south on one pad and west to east on another pad. So that's going to affect the amperage a little bit for the tire scraping across it. But I don't know, something we can test. We're already set up. So let's do that. All right, so I got my regular used rope against this soft shackle, or the Factor 55 soft shackle with their retention pulley on that black waxy rope. It didn't spin at all, hardly any. Sometimes it did, sometimes it didn't. But we'll look at that and see how it does on their shackle. No cylinders, nothing. We'll just look for amperage, I guess. Just do a quick test. stalled out, and it still doesn't turn. That's interesting. Let's pull this out. I'm gonna swap it out. All right, so I swapped out for my DIY shackle, and we'll see how it spins compared to the factory 5s. We'll stop there because my electric fan came on. So. If anything, it's a good comparison test for worst case scenario if that pulley doesn't spin versus the other from between shackles. So that's good information. All right, so we have a whole bunch of information now, way more than I expected we'll get, but we won't go through every little bit of this, but we'll skim over it. So the benefit of having 2 cylinders on this test is to see our total efficiency. So each run can be compared with itself in that sense, because I mean you're pulling across concrete, the surface finish on the concrete, not to mention that when you pull the tire, drag the tires one way and you roll the tires back, now you're on a fresh spot, and after all these tests, eventually I know a spot that was clean and drug went over the same spot again, and maybe some more resistance and load. But since we know the total load of both sides of the line, we can actually calculate the efficiency of that one single pull to itself. I know during the test we were kind of really close to the lines, but given synthetic line and how low kinetic energy that it has, if the line were to snap, it's not going to launch those cylinders in the air. They don't have the stretch. That rope does not stretch to do that. I mean, it'll shoot by itself across the field, but it won't pull a cylinder, something that weighs 20 pounds across, so we're kind of one of the things where I paid some buddies a t-shirt and some stickers, and they risked their lives to help me make this video. So thanks again, Richard and Dennis, for helping me out with that. So since we did 2 cylinders on this testing, it allowed me to see the actual winch, the PSI at the winch side and the PSI pressure at the bumper side, which will let me calculate the actual pounds force on the winch side and the bumper side individually. So of course, adding those 2 lines together will give me the total line pull, which of course across all the tests, they were fairly consistent. I mean, granted the conditions and all that. I mean, so also of course did the voltage across this so that we know how much watts. So, we have my draw more amperage down the line, because I mean, we're not really stopping doing between tests. We're setting it back up, rolling the truck back, and maybe 15 minutes in between tests, let the truck idle the whole time to keep the battery charged as best as I can. But at least as the voltage goes down, the amperage goes up, so we'll be able to calculate the watts on that. Basically, when it comes down to it, 1-to-1 pull, the most efficient pull you can get. But then, of course, on top of that, you're also drawing 2,500 watts to do so. And the actual next efficient thing is the actual snatch block itself, the actual old school pulley here. That was actually 91% efficient. So that's, that's great. Well, whenever we use the Factor 55 retention pulley here, and we had a little bit of slip, which means that the rope is actually slipping inside the pulley groove itself and not slipping like I guess it's designed to slip. I mean, it's actually 81% efficient on that, given those numbers. And on top of that, we had another pull again. Same thing, same test, repeated the same pull, and we got very similar results back to back on those tests. For whatever reason, the rope ended up slipping inside, and I really have no idea why. The only thing I can think of is it's that black coating that synthetic rope has. I had some black rope I ordered, and I made some soft shackles, another batch, and that rope left like a tacky feel to it whenever you tighten the rope up to itself. It wasn't like the rope that I use on the silver ones on these shackles here. These are real smooth, and you really don't feel the coating, but like this one here is like a waxy coating. It kind of sticks and makes noise. I mean, it's hard to explain, but that's the only thing I could think of is why it was slipping inside. But either way, we went ahead and tested that, at the end. Yeah, we were really surprised on that with the slip. So granted, this one here with their soft shackle here, which for whatever reason, I guess the way the finish is, didn't let the rope slip inside the actual retention pulley. Basically the pulley stayed solid. I mean, did not move. So it was 100% seized up. And just like what we thought, you're going to actually have more pressure on the winch side than you will the bumper side. Just that simple. I mean, it makes sense. At least our theory's proven correct. But even on this worst case scenario where this pulley is completely locked up, it still was 79% efficient compared to the ideal run where the pulley did slip. The pulley did not slip inside, and it's 83%. All right, moving on to some graphs, just maybe a little bit easier to see and read. But this whole scale's in watts. I mean, the maximum we had right here was about 2,700 watts, I think. Actually, 2,500 watts, and that was our one-to-one pull. These are the rest of the pulls with the combination of the pulley, which is the lowest one actually. It's the green one. And then the Factor 55 stuff's all right here. I mean, depends on the variance. And worst case scenario, I mean, there's not that much difference. It's really not. It's, you know, basically not even a couple hundred watts between the two. So as far as the force lost in pounds, I mean, the most inefficient run was the 100% slip. That was the most inefficient run. That's whenever we used this coupled with their pulley, and it did not turn at all. And that was the result that we got for that. So, but look at the efficiency though. I mean, really, I know it's a small scale to 750 for this next bar, but even so, it's not that much difference between it. So it really doesn't matter if this thing slips on the outside, if it slips on the inside. I mean, the way they have that thing Teflon coated apparently does not matter whatsoever. It's just going to keep going, and it's going to be a successful pull as far as with its own efficiency in itself. Here's another graph comparing the actual force for the bumpers itself. So we got our actual pressure on the winch side here, and then this is the one-to-one pull right here on the top. So that's the straight pull, the most amperage, the most force on that one single line. But then of course using each snatch block, dividing that force by half, you can see how closely everything is as far as how close it deviates from itself. It's not very much. The total line force did vary a little bit right here. So the total line force did vary a little bit, but I mean, we're pulling on concrete, just the way the setup is, it's not 100% reliable. This is not a scientific test jig. It's just me pulling a 6,000-pound truck across my driveway with the brakes locked up. These results match what my first test did, so it's good to know that it's repeatable in that sense, where all these values aren't going to be wild and in left field. But the force in the bumper, of course, our 2-to-1 snatch block had the most force on the bumper, so that means it spread the load 50-50 the best across the lines, because this is the force on the winch side and this is the force on the bumper side. And of course, as the pulley gets seized up or there's more drag on that pulley, the more force you're going to have on your winch, and then the less force you're going to have on your bumper side. That's the data for that. I will say I appreciate Factor 55 for sending me that Haas. That aluminum Haas is just awesome. That thing's badass. My first setup with this actual X2O Haas, I mean, the radius bends on this is nowhere near as good as Factor 55s. I always had a little fuzz on the end of this, on this line here, just from the line dragging across, making a lot of friction. And their radius bends and chamfers are so generous on that I didn't have a single piece of fuzz on it. Definitely worth the $80 or whatever whichever model you get, but definitely worth it 100% to get that. This thing, I mean, it's not trash, but it'd be nice just to have. I know I can do more extreme angles on it and do more extreme angled pulls and not have to worry about my line snapping against something. I mean, it's not really sharp, but relative to much forces on that rope on that little small edge, it's pretty sharp in that sense. So, like I said, even the backside's chamfered very generously on the other one compared to this one here. I hope you guys found that information useful. Hope you guys at Factor 55 finds this information useful. I mean, I'm actually very surprised on how little drag there is between it being 100% locked up and, not locked up. I expected that to go through the roof, to be honest. But as far as the heat goes and everything else, I mean, it basically does not matter. The product will work regardless if this thing's spinning around in circles or not.